So at this point, we're pretty much ready to wrap it up. The only thing left to do, I think, would be to adjust, make sure that the minimum height is set to 0. If you look at this from a side view, pressing spacebar 3, you'll see that the minimum height is a lot below 0. So to take care of that, we can just create a transform node and negate the minimum dimension in y. So I'll use here the same expression as we used before. So it's going to be bounding box from input 0, and we want to grab the minimum y dimension, and we want to negate this value. As you can see now, everything pops up, and we can see that we have the minimum height set to 0. Let's rename this min height to 0. And let's do a quick recap of what we've done so far. So we're inputting 2 point sets, one for ground and one for unclassified points, which will usually be the vegetation. We have a couple of deletes here to reduce the density of the points, and we assign groups to each one of these group sets. Point sets, one group for vegetation, one group for the ground, and then we merge them together, bring them to the origin, orient them properly, make sure we have square section of a terrain, and after that we go into the process of calculating the average distance so we can eliminate any stray points that we have, and finally we set the minimum height to 0. Now it would be nice for us to, at the end of this, kind of split the points into their groups after they've been processed. So we can use actually a split, and we can split the ground group. Let's create a null. So this will be out ground points, and on the other output we're going to have out vegetation points. Now we have this set of points and this set of points, and we should be okay. Let's see, make sure that everything is okay. So we seem to have discrepancy here in terms of the size. Okay, so to solve this problem, what we're going to do is here, when we're creating this node, the bound to determine what is the bounding box for our points, we're going to calculate the bound for the ground only. So we'll apply a blast here, and we'll delete everything that's not ground. So if you want to negate something that's not ground, or you can just delete non-selected. So okay, so now we only have the ground points, and our bound is adapted to that size. So when we calculate the section that we want to eliminate, we're only going to get rid of that extra margin that the vegetation points was having. And finally we can bring this in and put this back in the same place. Okay, so everything is as before. The only difference is that we made sure that the bounding area that we're considering only considers the ground points, so we don't have that discrepancy on the margins. And the final results should now be more consistent. We have the ground points and we have the vegetation points, and now everything is in order. Now we'll convert this to a digital asset in order to make it easier for us to access some options, and it'll be easier for us to insert or introduce other lidar data that we download from Open Topography, for instance, and everything will be done automatically. We'll just expose some of the parameters and some of the options that we might find useful, and it'll be also an interesting process to go over.